Would you be my girlfriend, babe?
Hello, can you hear me? Mohit. Hello, Mohit. 1 minute. Can you hear me? Already 6 likes. Damn. You're having more likes than viewers. Somehow. Okay. So we have two viewers. I hope one of it is not one of it is not me. So I will try to solve problems for from 800, 900,000 up to so on. I may struggle at 1500 or 2000 because I can't solve them. But in this stream, I will try to solve 800, 900,000 up to so on as long as I can go. And you guys can see the difference between the adjacent ratings, because you may think you can solve 1200 but you cannot solve 1300, or you may think you can solve 1200 but you cannot solve 1700. So if you see each rating, maybe you will know that there is not much difference between any of those ratings, because ratings just a number likely, because there wouldn't be much difference. All of them use the same thing. So yeah, I will just try to solve from 800, because last stream I tried solving 2000, but then I was not able to solve them. So I thought, okay, I should go back to 800, because then at least I can solve some problems. So I think, yeah, we have 5 viewers. 5 viewers is a lot. So I'll just go start solving. Do you guys want some music by then? It will against a copyright or something like that.
Baby, you got something in your nose. Sniffing that K, did you feel the hole? Hope you find peace for yourself. New boyfriend ain't gon' fit.
1 minute. I won't struggle this much on 800 problems. I'll just make this folder. It's fine. I'll just open it and solve problems. Oh, we have 6 viewers. I think that's like the max number of viewers I had so far. So the thing is, the only rules are, I'll write it here. Only rules are to solve some problem in that rating. I won't go for like the easiest problem. I will just go for random problems, but I will read multiple problems at times, because some problems are easier than others to me. So yeah, let's just start with 800. I know most of you guys or some of you guys can solve 800 problems. Yeah, okay, sure. I'll select that for 1300. I know some of you guys cannot solve 800 problems, so let's just see how to solve an 800 code forces problem. This decks. Monograph plays 3 decks of cards in a row on a table. The first deck consists A cards, B cards, and the C cards, strictly increasing ones. Monograph wants to take some number of cards from a third deck and distribute them between the first 2 decks. Take some here and distribute them here, so that each of the taken cards ends up in either first or second desk. Yeah, it won't end up in both of them. It is possible that all cards taken from the third deck will go into the same deck. Okay. Your task is to determine whether monocrap can make the number of cards in all 3 decks equal using the described operation above. So yeah, we all know this is an easy problem, but the first observation that we all make here is the final equal value is fixed, which is sum by 3. So this can be our first condition. And if this value is fixed, other necessary conditions. So all problems, most of the problems are about finding enough necessary conditions so that they become sufficient. Do you guys see this statement? Even though it's an 800 problem, we are using the same logic again. That, I know I don't want to explain 800 problem for long, but if you see what we are doing, most of the problems are finding enough necessary conditions. But if you find enough necessary conditions, they become sufficient. So let's say this is one necessary condition, that sum should be divisible by 3. And other, what are other necessary conditions? B should be less than or equals to sum by 3, right? If B is greater than sum by 3, whatever you add to that, you cannot make it equal to sum by 3. So that's another necessary condition. A should be less than or equals to sum by 3, but it always happens because A less than B less than C. So now let's look at our necessary conditions. If this necessary condition satisfies and if this necessary condition satisfies, we are done solving the problem, because both of them are less than sum by 3. Total is equals to sum. We can just make this by taking some cost from here equals to sum by 3, and we can make this also equals to sum by 3. So if you find enough necessary conditions, then they become sufficient. So while solving problems, you have to keep finding necessary conditions, and then you have to prove that they are sufficient. Why you cannot solve some problems sometimes is you won't prove that they are sufficient. You won't even think, okay, are they sufficient? You won't even think about the logic. Okay, I should not talk more for this 800 problem. Int a b c scene a b c int sum equals to a plus b plus c if c out sum remainder 3 equals to 0 and sum by 3 less than or equals to b, else no. See, now I know very clearly that this is enough because I have proved that this is enough. Otherwise you will think, okay, should I add sum by a, sum by 3 less than or equals to a, or you will think maybe if this goes wrong I will submit something else. I know it's just an 800 problem, but I'm just still telling that how you guys solve without clarity. Clarity is important. Why is this wrong? This should be yes, right? This should be yes, right? 18. 18 by 3 is 6. 6. Okay, sorry. B less than or equals to sum by 3. Yeah, we should be careful too, because on streams I'm talking half the time, right? So some of my brains can't even solve 800 problems because of that reason. Because on streams we cannot solve 800 problems. So it got accepted. So if you guys have, some of you guys have never gotten an accepted on 800, this is how it's done. See, I'm going to use the same logic of finding enough necessary conditions so that they become sufficient in most of the problems, and you guys will see that in future. But I'm going to use the same logic. So 800 is done within how much time? We started at 12 let's within 10 minutes we are done with an 800. See, that's a success. No person exists of such time. People scare. People piss their pants when they hear code forces. They go to leak code and then do some code. So I think there are people, surely people. Indivisible seems like a new name. Good arrays also seems like a new name. Let's just try to do this thing then. You're given an array of positive integers. So if 800 is a easy one for you, Mohit, what about 900? And then we'll just increase 100 and then we go to 25 or 26 too, right? In this stream. I'll go as long as possible. I don't think I can go till there. I can, I think. You're given an array of positive integers a of length n. Let's call an array of positive integers b of length n good if all of them are not equal like verticals and the sum should be equal. Does a good array exist? So what we want, again, I will again try to use the same logic. I won't even think about what to do in this problem. Question we want to think about is, does a good array exist? What are the necessary conditions? Necessary conditions means what follow if a good array exists. So a good array exists implies. So now what we are trying to find are necessary conditions here. And once we have enough necessary conditions, it will become sufficient. And when it's necessary and sufficient, we know what exactly a good array exists means. Then we have necessary and sufficient conditions. So a good array exists means these conditions implies and implies. Then we just submit this as a code. So if a good array exists, oops, it's shocking. My laptop is shocking. Yeah, I removed the charger. Now it's not shocking. Mm, so AI is given. So some of BI we know. Uh, some of BI we know. So if n is even, I think all of them should be positive. This is a restriction. All of them should be positive, right? If let's just keep this also aside because it may not be logic. If all of a or one, we can do it. We must. So this is a small observation. If a of I equals to 1, b of I must be greater than 1. So we have more number of b of i's, b of i's, b of i's and all, right? All of them must be increased. So if a of I equals to 1, the positive constraints restricts that b of I is greater than 1. So let's just say whenever a of I is 1, we keep b of I as 2. Ones are the problem here. And if we keep b of I as 2, and then uh, let's just look at all ones and non-ones. See, all ones must be increased. All ones must be increased. There is no restriction on to. Another observation is there is no restriction onto how much you can increase, but there is a restriction on how much you can decrease. On how much you can decrease, because we can increase one element, the maximum element, or not even maximum, because we want AI not equals to BI. We can increase any element to any extent. So we can increase as much as we want, but we cannot decrease as much as we want. And we have something called we must increase these things. So all of this must be increased. So let's say C1 is the count of 1. This much must be increased. So we have to find how much we can decrease this one. How much we can decrease is sum of AI greater than 1 minus 1. So all of those AI which are greater than 1, we will make them 1. This is the maximum amount we can decrease. And now this must increase is less than or equals to this thing, we are done. Do you guys get this one? This is fine, right? Because it's a 900 problem, you guys can understand it too. We have 5 viewers. I think this is good because this must be increased. And we have a restriction on how much we can decrease. Ones cannot decrease. Only greater than ones will decrease. And how much max we can decrease, we have a restriction on that. And we must decrease all of them too. Let's assume we must decrease all of them too. But we can increase something as much as we want. So we'll decrease few things and increase one thing as much as we want. So that's never a problem. Like decreasing few things, decreasing greater than ones, and then increasing something. If something doesn't exist as one, we can use one of them itself to increase them. So that's fine. The other case is fine. We can decrease all the greater than ones to something smaller, and this is the only condition that may go wrong. So that's enough to just submit it. Okay, I struggle a bit with the 900 because proving it is not uh, too direct. I mean, it's direct because the cases are when we decrease greater than ones, we can increase some equals to 1. If those doesn't exist, we can increase greater than 1 itself, some greater than 1 itself. For that, we want n greater than to be 2, uh, which is obvious because when n equals to 1, it's none. See, in the proof itself, we know for something else to exist, n should be greater than 1. So corner cases will come from the proof in general. Mm-mm. Int, I'll just have count of ones, sum of greater than ones. If a of I equals to 1, c1 plus plus, else sg1 plus equals to c1 minus 1. Sorry, a of I minus 1. Right. And our condition is this sum, maximum how much we can decrease. And also, if n equals to 1, return 0. And now see out. So this much amount we can reduce, and if n greater than 2, we can choose one thing to increase. And so let's say we are trying to reduce all the greater than ones to ones. Now we came so down, and let's say there are some ones existing, all of them will be increased. So the amount we decreased is greater than what we have increased, so we can slightly go back and make that work. You can slightly go back and make that work. So one question now in this argument is, when we go back, will something again become the same as where it was? It wouldn't, because if if it has become, we won't increase it. What we will do is we will increase this further, because we have reduced it. We will increase these things further. So make all the greater than 2's to 1. Now if there exists some 1, we can increase that 1 to as much as we want, so that all the decrease here will match to here. And if there are no ones, then we can choose one of this itself, and we never decrease it. We make other things to 1 and we increase this. Even then it's done. So n greater than 1 means two things will definitely exist. So this is hard killing. This is like overkilling a 800 problem, but 900 problem. But that's the difference. If you actually prove things very clearly, then you can solve 2500 problems, 2500 rated problems or 2600 rated problems. Because if you just make those logically, you need not even prove as clear as I do or as mathematically clear. But to yourself, you have to understand that okay, I am doing this clearly. Okay, maybe this is the reason why it would be correct. You have to prove it to yourself. That's the difference between easy problems and difficult problems, where you may seem to make wrong answers, but others seem to submit them because they might have given some importance to proving it. Yep, easy one. Share the link somewhere. We need more viewers. We need at least 5. I will do 1000, 2000, 3000, but just share your link to some people. Some people will be jobless, right? Like me, like they will be jobless. They would not have any social life on Sunday. So they'll probably come and check it out. So we're going to 1000, 4-digit rating. There are no 5-digit ratings. These are the final 4-digit ratings that we are going to solve now. Shotgun seems a good, but it's a bit long. But let's just read the problem. Yeah, so share to others people too. I think it will work. Maybe just share in some at some places. More fans to you. Someone is telling. Contest discussion, bro. Also looks really good. What the fuck? Damn. Mm, yeah, we have 5 viewers again. So we have solved successfully 800, 900, and then we are now at 1000. I hope you guys can still keep up with the amount of logic we use in 1000 rated problems. And hello, Gracil Unadkat. Hi, Gracil Unadkat. Show some grace and stay till long. Lokesh, isn't it too long for you? Like, it should be like night 3 a.m. or something, right? Because you told you're somewhere else in the world. So now we are solving a 1000 problem. Even the 1000 rated, even the 1000 rated problem is 4-digit. We won't get scared. We will read the problem. Sunit and Slavik play a card game. The rules of the game are as follows. Each card has a number between 1 and 10. Oh, that seems simple. It's not 1 and 13. What kind of cards are they playing? Each player, maybe numbers, integer values. Maybe the AK11, I mean AK or not numbers, right? That's why they haven't mentioned them. Each player receives 2 cards, which are face down. So a player doesn't know their cards. Okay, the game is turn based, consisting of exactly of 2 turns. So each of them has 2 cards. They don't know what they are. The game, this is 1000. See, the problem can be exactly like this, and it can be much harder problem. We don't know the difficulty of the problem, so there is no way, no reason to get scared of E, F, or anything. Really, you have to give your best try before getting scared. I'm not getting scared of a div 4b 1000 rating problem. I'm just telling the general rules. The game is turn based and consists exactly of two turns. In a round, both players pick a random unflipped card and flip it. So we have four cards. Each one has two cards, two cards. The game is turn based, consisting of exactly two turns. In each one, both players pick a random unflipped card and flip it. So both of them will try to randomly select one and flip it, flip it. The player who flips a card with a strictly greater number wins the round. In case of equality, no one wins the round. A player wins in equality. Okay, numbers can be equal to, so it's not distinct cards. A player wins the game if he wins the most number of rounds. In case of equality, no one wins the game. Since Sunit and Slavik are best friends, you need to calculate the number of ways the game could happen that Sunit would end up a winner. So we know the cards of Sunit, A1, A2. We know the cards of. Wait, what bad framing of this problem? They never mention what's A1, B1 are. Okay, they mention where A1 and A2 represents the cards Sunit has, B1 and B2. So both of them don't know. They randomly flip. We want to find number of ways. So we have to understand what number of ways means. Uh, this is a thousand rated problem, but still, like, we have to understand what's the number of ways, right? Could happen. How do we differentiate two ways? So in first round, we can either randomly choose A1 or B1 or A1 or B2. There are like uh, four possibilities: A1 or A2, B1 or B2 in the first round. And if the first round is fixed, second round is already automatically fixed. So is it total? Is the total number of ways four? That's what I just want to check. Consider the first test case. It seems so because 10, 10, 2 to total number of ways are 4. So this is a simple problem again. We can just brute force among all possible ways and then it's done. So let's just code that too, because we know all possible ways and then we can just brute force. Wait, why is this even? I think the previous problem is more difficult than this problem, I think, right? It's just brute force, asking for brute force. Maybe that's why it's division 4. I should not spend time here, I think, then. Int A1. Should I do A1, A2, B1, B2, or should I do A of 2, B of 2, C, A of 0, A of 1, C in B of 0, B of 1? Who should win? Sunit should win. We want to count number of wins Sunit does. Int answer equals to 0. For int I equals to 0, I less than 2. I mean, this is an easy problem. So let's see how an 1100 will be. You guys will get scared at 1600 itself. So 1100 is also a lot higher rating. If you think 1600 is higher, 1100 must be higher. So all possible ways we are going after. I equals to 0 to 1 will make number of different ways the first thing can be chosen. All possible ways are just 4 because once you decide what has randomly got chosen in the first round for both the players, second round is fixed. So that's it. We're still getting wrong answers. 3 greater than 2, 8 greater than 6. Why am I making such mistakes like in this stream? Am I not being. Okay, now let's see what went wrong. 3 greater than 2, right? 8 greater than 2, right? 8 greater than 6. So this should be right. This should be. So this is not the way, I think. This is not the way. This is not the way. This 2 will represent. So this 2 will represent the way a game can be done. Right? This 2 will represent the way a game can be done. Wins. Now let's count wins. Wins equals to A of I greater than A of J plus, this is the first round win, plus B of I, A of 1 minus 2 minus I, 1 minus I greater than B of 1 minus J. The other card also winning. And if wins greater than, if both of them, if answer plus equals to wins greater than 1, because he should win more matches, then it's considered a total win. This should be right, right? Guys, help me out with this 800 problem, 1000 problem, please. 3 greater than 2, 8 greater than 6. At least in this matching, we are getting 1, right? Answer plus wins greater than 1 because A greater than B of I plus 1 minus. What's wrong here? Does anyone identify mistake here? I'm doing this because so you guys will learn debugging, like because debugging is critical, right? In thousand rated problems. So did you guys identify the mistake in the code or no? So this will help us identify the mistake. So we have 3286. This should have made it 1 plus 1, and 1 plus 1 is answer should have increased. Here answer should have increased. Why is it 0? Here answer won't be 0, won't be more. Again here answer will be more, right? So let's output wins too so that we know what's going wrong. See, wins is always being 0. Why? Should we use brackets? Do I not know such a thing that we should use brackets in these things? Yeah, that should be the case. Okay, I never used two things in a line. Maybe that's the reason. It would have been better if you do wins plus the second game, wins plus the first game. So if this is the case, let's just submit it. So this is done too. This is just brute force. This has no logic in it. All the logic it has is to count distinct number of. We are done, guys. Wrong answer on test. We won't see test cases. We only see the code again because we cannot see test cases. Can it be more than 4? What does number of ways mean? Baby, got something in your nose. Slipping that can. Did you feel? Guys, anyone help me debug this? For each win, there are two possible ways. How? So, what are total number of ways? 8. Is it 8? It's just 4, right? Yeah, that we are counting, right? See, all the different possibilities are uh, choosing first card randomly and choosing second card randomly, first card of both players randomly. And once that has been chosen, yeah, that we are counting. We are counting that, right? See, uh, see here, 3286 will be taken, and then in the next time 8632 will be taken. So that we are counting. I think there is some other small mistake. I'll just once review it. I think some rounds may draw, right? We have to just take care of draw because if person one wins and the round one is one and round two is draw, still we are winning. So let's just wins A equals to wins B equals to, because there are draws, so let's just make it more clear. Damn, this is not so simple problem then. So this is the mistake we made, that assuming that sum of wins equals to 2, I thought sum of wins will be 2, but no, sum of wins may be 1. There may be only one win, and then, so this is the error. I assume few things. I assume that like sum of wins, we have to be more careful. We cannot just solve the problems on. I think. Do you get the error, Durgesh? Because the error was not what you have mentioned, but the error was what I have just found. The error was assumptions. I made an assumption that total number of wins will add up to 2 in each game. That is likely not true, because we have to read the rules more carefully. See, if I don't think, if I do them instinctively, I think I can perform better. So, because our viewers are dropping, I will just try to solve them first and then maybe talk about it. So, we got the problem too. So, now we are going to 1100. Guys, I'll just go a bit serious because I think we are fucking things up. So, I'll just try to go a bit serious. So first numbers are the same. We are having n into k times, like as if the array has been kept like that. And for any I greater than all, it holds that vi equals to I minus 1, which is nothing but repetition. 2134, 2134, 2134 k times. Given a number x, it is required to count the number of such positions for which there exists a position r greater than or equals to l. Given a position x, uh, we are required to count such that how many segments are there, such that the sum of elements in the array B is at least x, in other words, greater than or equals to x. Okay, this seems to be a bit direct problem. So we want number of segments, number of subarrays of size greater than or equals to, I'm not writing problem statement. We want number of such L's that satisfies some condition, which is L2 or greater than, is it greater than or equals to, or greater than x, or equals to x. Taking r equals to n into k is the best thing anyone can do. So this is the first statement, that important statement that we have to make. Taking r equals to n into k is the best always. And now we want total sum, which is equals to sum of a times k minus prefix sum of uh, prefix sum of prefix sum till l minus 1, greater than or equals to x or not. We want to see number of such L. I think this is enough. We can just brute force this in some way. We can just brute force this. Okay, because now k things. All of this may satisfy. All of this may satisfy. All of this may satisfy, and then some segment will only satisfy till half this condition, right? So we can just do that. Uh, so we will just do that brute force. So it's just brute force. Assume like this are repeating. If all of these are satisfied, we will skip all of them and then go to the next thing immediately. And then when we go faster, like skipping, at one place we cannot skip all of them. Then we go one by one and then count it, and then it's done. I hope I'm not being very unclear, because things got repeated. It holds true, but then it fails at some point. Instead of because it's repeating, instead of going true, we will go like this. So first time we have k segments. Let's go over those k segments. Okay, but before that, let's get our sum to. sum of a equals to 0. Let me add this to sum a to, sorry, it's not just sum a, it's just sum a. So let's see if this whole segment satisfies or not. If this whole segment satisfies, which is nothing but, we'll have our answer here. We are just brute forcing. We are trying to see if this whole segment satisfies. If this whole segment satisfies means, even if you all of this, if you remove, the sum should be greater than or equals to, not all of you if you remove, but even the last thing should be satisfying the answer. So which is nothing but a of n minus 1, the last thing, plus k minus I minus 1 times sum greater than or equals to x. So first thing satisfies, second thing satisfies. We are trying to see if the last thing will satisfy, last L will satisfy. If the last L will satisfy, answer plus equals to n. Else, this means the last thing is not satisfying, means only few of these things will satisfy. Now what we will do is, we'll just have cur equals to cur sum. So far the sum is this one. Now for each L equals to 0, L less than n, L plus plus, we're just brute forcing cur plus equals to a of L. This is not the way, because we have to come from behind, right? Let's just come from behind. So now we know this first curve where L equals to n minus 1 will not satisfy, because we have already checked that it will not satisfy, but still after some time some may satisfy. So if curve greater than or equals to x, answer plus plus, this would be enough. So it's just brute force and realizing the fact that you can go over segments one after the other a bit faster than it's needed, because you can go over them a bit quicker, and then once you cannot go over them quicker, you go after them one by one. This cannot be time limit exceeded, because after this we have to break. We have to be a bit careful, because after that we cannot keep doing the other things, right? In contest, I mean, I got the solution, but still, we got the solution and idea, but still, we should be careful that we don't do such mistakes. See, binary search is also not needed here. Do you see, Lokesh? I have not even used binary search. I just used the idea that, okay, it's repeating. Because it's repeating, n into k is too big, but it's repeating. So we can directly check if all of this will satisfy by checking the last element. And then we can directly check if all of this satisfy by checking the last element. So I must just keep going like that. And once I cannot go, its idea is a bit similar to binary search, but yeah, it's a bit similar to binary search, but yeah. See, these things will also occur in n root n idea. We have square root things, right? Yeah, a bit, because here it's not needed. So yeah, so this idea that I have used right now, this will also come in n root n. When array is like of length n, we may split that into root n segments. Now if we split that into root n segments, we can do things in n root n complexity, which is we try to go over all the root n segments, yeah, I think. And then we can use the n root n logic like in many cases too, like the n root n logic. Many problems will only make you want to split into two cases, where some n root n will also come in like not reminder. If a into b is less than or equals to n, it's either a less than or equals to root n or b less than or equals to root n. Even in those cases, we can use n root n. Okay, but if you leave this, yeah, this I have solved quicker than the previous problem, right? Because I thought I will do a bit seriously, because viewers are dropping. So 26 to 40. This was 14 minutes, but from here it was just 6 minutes. So let's try to solve some other problem. What rating are we at currently? We are at still 1100 and we have a 1200 problem given by Mohit. So let me just solve this. Let me just solve this 1200 now, and then I'll go to the Mohit, whatever the Mohit has given. I'll clear these things. I think it's fine if I clear them because we have our problems here. We can open the problem again, so it's fine. So now 1200, and then I'll solve Mohit's 1300. Yeah, good night, because you will you have to sleep. That guy is staying somewhere else. He's not sleeping in afternoon like an old uncle. He's living in some USA or somewhere, it seems. So he's sleeping now. Yeah, good night. Uh-huh. Yeah, so now we are at 1200. Place of the Olympiad, several and final mix. I think this sounds a bit better. Instead of strangers also sounding like a good name, but let's just go for mix. I've been shouting, guys, so I'll just have some water because I've been shouting. I'm not scared of serval and final mix. I'm just trying to get some water because I'm definitely not scared of that. I'll just solve it. I'll get some water and solve it. Say this is ICPC shirt, ICPC hoodie. I got it in ICPC World Finals in Kazakhstan. Where is that Kazakhstan? I'll come in a minute. Yeah, now we'll try to solve 1200. So newbies, if there are any newbies here, 1200 is like your not solvable level, right? Because if you can solve 1200 in contest, damn, I got 2230. I used to be 2229. But after rating rollbacks, I got 2230 now. I was good here, a bit, and then I messed up unnecessarily in last contest. So 1200 is pupil level. So we are crossing a level. Not just shirt, I think. We even have ICBC bottles. Just joking. We even have ICBC cube. 4x4. I'm just joking. We even have ICBC note. This is too much. We even have dot fancy. Yeah, so let me solve 1200. Given an array consisting of n greater than or equals to 4 non-negative integers. See, we have to give importance to everything that I have told in the question. You need to perform the following operation on. Yeah, I'll try to solve this also quickly. I think you guys can keep up. If you guys want me to slow down somewhere, there are so many shitty things. There is a soap. There are some weird cubes. There are paints, acrylic paints. There are so many things. There are lemons, which you wouldn't expect. There are scissors too. Yeah, so let's try to solve the problem again. I think it's not morning, I think 3 a.m. Guys, let's focus on this problem now. Should I keep the links so that you guys can open them easily? Should I keep the links here like this? So focus on this problem, because if you don't focus now, when the problem rating just increases one by one, and it becomes 1200, or sorry, 2200, 2300, then you will lose. You have to be focused throughout the stream to solve the problems correct. So just on these streams, don't focus on the lemons that I'm showing. Focus on the max problem that we are doing here. You need to perform the following operation A on A until it becomes length 1. So we have a length greater than or equal to 1. We have to perform the operation until it becomes 1. Select two indices L and R. Replace the subarray with single integer max. So it will turn into its max. See, whenever there are operations, that makes our life simple. All we have to do is do a bit work on the operation. That's the first step. Whenever there is an operation, what logical statements you can make on that operation is the first step always. The array, I mean, I know you guys will not solve systematically. You guys will just solve, okay, 1200, I'll just try to do some random things, and then I will get something, and then maybe it will done. But then you have to do things systematically to solve any rating. uh, so we replace that with the max. It seems length of array will decreases by this much. We know that r minus l only, r minus l means all of this got removed. uh, Lengthwise, so serval wants the final element in a to be 0. Help him. We have to also output operations. So we have an array, we want to make the final, we have an array, we have an operation, we want to make it 0. When is it possible is the first question, and then we can think of how is it possible, because if they're asking you to output everything, then it's even easier problem. So first question can be, when is it possible? An array, an operation wants final element to be 0, right? We can choose a subarray. Small observations can be, if there is no 0 at all, then done. If there is no 0 at all, then we can take the whole max and then it becomes 0 in one operation itself. Now problem is with zeros now. So if there are some zeros, okay, the 0, whenever you involve that 0 in some operation, it will lead to some 1, right? But we don't want to make everything as uh, I mean, when we eliminate some zeros, let's say we are trying to eliminate all zeros, okay? Okay, when there are zeros, just consider zeros now. Just consider 0 as, okay, problem is with zeros. Eliminate 0 by considering just that element. So just consider that I comma I, L equals to I comma R equals to I, then the 0 becomes 1. L greater than R. So we have L greater than R, so we cannot do that. It's given in red, so the problem changes. See, just by greater than, less than, or equals to, the whole problem changes. So when the problem is complicated, you guys should not get scared, because just one simple fact may be simplifying the problem, which you are not using yet. Do you guys get what I mean? Damn, bro, if I cannot solve this problem now, we have to switch places and you have to solve and I have to hear. Uh, so yeah, we cannot choose I comma I. So let's just see if we can choose uh, the first 0 and the last 0. Let's say, if let's consider there are, see, if there is only 1 0, we are done. We can take I comma I plus 1, and then we will be left with at least 3, size of the size 3, and then we are done. If there are 2 zeros, let's just see, if there are 2 zeros, let's just see if they are adjacent or not, right? If there are 2 zeros, if you can split them into, if you can split it into arrays size greater than 1, both of them, you can apply OP on them, and finally you can apply OP on 2 elements, because we should not make it into 1 element, right? So if there are 2 zeros, if there is 1 0, we are done. If there are 2 zeros, if you can split it into such a way that both of them have size greater than or equals to 2, we are done. Is it possible or not possible? Because it's not possible only if the first 0 and the last 0 are like very close in the beginning. Then if you split those 2 zeros, then it may not be possible, right? So simple thing is, take a of 0 comma 1 and a of 2 up to so on n. I think this would work, because in this split, if both of them has no 0, we just keep it intact. If both of them has no 0, again we will keep it intact, and then we just apply it to the whole. But if this has a 0, we can apply operation on it, and then it will become non-zero. And then if this has a 0 or non-zero, based on that we can again apply or not apply. So we can make this as non-zero and this as non-zero in very simple operations, and then we apply final this thing to make everything 0. So it's simple now. All you have to do is if there is a 0 here or not, and if there is a 0 here or not, then we are done. So it's a simple problem again. See, this problem has something to try to see what will work or what will not work, and then there are hints, like you have to be careful with the 0. And if some subarray contains 0, it will become non-zero, and if it doesn't have a 0, it will have a 0. And finally, to make everything 0, you want two non-zero things so that it becomes 0. So most of them are like very clear. So if this is non-zero, initially we will just keep it intact. If this is non-zero, we'll keep it intact, we'll apply to the whole. If one of them is 0, we apply once to it so that it becomes non-zero, because if you apply max on 0, it becomes 1. So what this problem is doing is just some try. If you think max problems I cannot solve, maybe I have to see some Bayaka max videos on YouTube, only then I can solve that problem. That's stupid. You should not make such assumptions that okay, I cannot solve this problem because of some reason. You have to just try to apply some logic, which you can. There is no bad logic here that you cannot apply, right? This finally, the solution is too simple. See, the solution is this simple. Just consider this and consider this, because we want size greater than 2. And I have observed the fact that 0 will go to 1 or 1 will go to 0. We want two ones finally. So just this would work, I thought. So on this would work. Is that clear? Yeah, just one small observation. So there is no point, guys. Whoever has not liked the video, like the video. I don't want to beg for likes and all, but just it seems fun to see like 9 become 10 or something like that. Yeah. Mm. So now think about the implementation. How simple it can be. I haven't even got scared about 5,000 or anything like that. So implementation is so simple. So how simple implementation is? I mean, this two will become one element, right? In that case, is it easier to just shrink them, or is it easier to split into four cases? I think it's easier to split into four cases, because so the four cases would be: is there a one in the first part? Uh, let's say L1 equals to 0, R1 equals to 0. Like, is there a one in the left part? Is there a one in the right part? Sorry, 0, not 1, right? We are concerned about zeros. Nice, brother. You have solved this problem in the contest. Yeah, you have to solve all other problems too, because we're gonna see that other problems are not that difficult. We're going to solve many ratings now. So because whenever we find 0, we are just counting number of zeros that are there, right? If L0 equals to 0 and R0 equals to 0, we can just output the whole array. And then we are done. I'm just writing four cases because why struggle with. I think in this case where there are cases, you can either write cases or you can try to brute force the whole thing. If you brute force the whole thing, you have to make this as one and then make this as one. I think instead of that, what it will become, I think it's easier to just write it all. Not or zero. No, 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 no. So this doesn't have a 0 and this has a 0. So what will our first operation be? Our first operation will be start from 2. It's Sorry, it's one based index, right? Start from 3 to n is the first operation. And then what's the second operation? Because this doesn't have 1, this doesn't have 1. Now it's again just all the 3 will become into 3. So 1, 2, 3, the whole thing done. And this should be 2. I have to be a bit careful too, even though I'm doing streams, I will become less careless. I mean, writing this will not take much time, so I'm just writing it. Maybe there are better solutions, but I thought writing itself, because anyway, after it gets it gets shrinked. We have to. There will be cases. I think it's unavoidable. Wait, should I increase this size, or what do I use in general? Maybe this seems too big, but so now we have to shrink first thing first. If I shrink first thing first, now I have to shrink. The length is of n minus 1 now. Now I can just apply to whole. Now it's 3 operations. The problem is like, see, at much higher ratings like 2500 or 2600, all the logic you have to use sometimes would be operations will be either 0, 1 or 2. That's it. They will ask you to find minimum number of operations. So it looks like, oh, we have to solve this complex problem and then we have to find the minimum number of operations. But then it may be true that always 5 is 4 is 3 is 2 is possible. So now you just have to split the cases where 0 is possible, 1 is possible, 2 is possible, and then it's done. So uh, such small observations, there are problems of 2500 or even higher rating where all the observation you have to make is that it's always possible to do in 3 operations or 4 operations. I'm just telling you how problems exist so that you will not have misconceptions that okay, difficult problems will use difficult things. So I think we have to definitely go to difficult ratings, because we cannot just stay here forever, right? We have to go to higher ratings. So let's just do this quickly. Let me just first string the next thing, okay, because then we know what it is. I'm shrinking the second part first, and then I'm shrinking this first part, and then I am just, now it's just 2 elements. We're done. So this problem is also not that difficult. Can I get attendance, like whoever exists? Can you say yes or no? Share again links, because people are not as focused as you people that are in the live chat, because people lost their attention span to the reels of Instagram. If you try to see reels, we'll get lost. It's loading.
And when I walk in, all that I want is you say, "Daddy's home."
You should not get, yeah, you can eat lunch, you can just say little bit, or you can go back, you can go and come back, that works too, fine. Share spam in some groups so that we get some viewers. I don't care if they are not like lasting viewers, they can just come and go still. If the number's good, that's good. uh, we have to see if this got accepted or not. Just case 5. 1, 2, 3, 4, 5. So we will make this as 1, and then we'll apply once again. Mhm, mhm, mhm. This should be greater than or equals to 2, right? See, in streams while talking, I thought in my mind, should I write I greater than 1 or greater than or equals to 2? And then I wrote I greater than or equals to 1. I don't know how I have done that. I thought, okay, should I write I greater than 1 or should I write I greater than or equals to 2? And then I thought I'll keep two, two, avoid any confusions. But then wrote one. I don't know how that has been done. Uh, Wait, was okay. Lokesh has to sleep, right? 1 minute. Oh, someone else texted me that I have fans. That's another Lokesh. There are two Lokeshes now. I think there is one Lokesh from Nellore who is a fan of me, it seems, but there is another Lokesh from US. Is it the same Lokesh? It's likely the same Lokesh. Sorry, it's the same Lokesh. How to save his number probably. Lokesh CH Nellore fan. I know he's not a fan, I'm just writing it like that. Yeah, it's the same guy. Sorry, yeah. Only fans. So now we have solved 1200. Now it's the time for 100. See, till now, did the level of difficulty increased? 1200 problem doesn't use segment trees, probably, right? What all it used was splitting them into two things and observing the fact that you can make 1 to 0, 0 to 1. Just that small fact. And if all are ones, it's 0 in one go. That's the first observation. And then if there are zeros, make it 1, make it 0. N greater than or equals to 4, we are using it very well by splitting it into first two and then next two is guaranteed. There n greater than or equals to 4 is being used. Otherwise, it will be a bit more complicated, I think. So, Mohit, where is your problem? Is this the link for that? So this was 1300, but I have solved this already. February 19, 2023. Damn. Okay, this was not my submission. This was one of my friend's submission because you can see it's bliss stage. We gave it like a team contest. That's why it has all these weird things. If I have submitted it, trash. I mean, I'm not blaming anyone at all. I'm just telling you. See, solution is simple. We know, but I don't like to keep template because why it will. I mean, if I am getting started into CP and if I see this shit, I actually got scared once because I looked at someone's template in the beginning. That's why I won't make my templates. No, 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 no. If I solve that again, you can check my okay. If I solve that again, that will be cheating, right? Maybe I will solve some other 1300. Okay, I will just okay, I haven't solved the problem. My teammate has solved the problem. So I have not solved the problem. I mean, whenever our teammate solves, we don't even look at the problem. So let me just check it again. Okay, let me read the problem. Yeah, because he's asking. See, we have 10 likes and 5 viewers, something no one else can achieve. We have such a likability, like not even likability, the usage, 2 pointers. We should not even see tags. You guys, if you guys have tags on, first you have to do is disable them. Uh, Beppa, and her circle of geek friends keep up to date on a group chat in the instant messaging app Swear Chat. Swear. The group has n members, excluding Beppa. So, other than Beppa, there are n people. Each of those members has a unique ID between 1 and n. When a user opens a group chat, displays the list of other members of the group, sorted by decreasing times of last seen order. So the member who opened the chat most recently is first in the list. However, the times of last seen are not displayed. Today, Beppa had been busy all day. She had only opened the group chat twice, at 9 and at 2. Both times she wrote down the list of members in the order they appeared at that time. Now, she wonders what is the minimum number of other members that must have been online at least once between this and this. So, in these two occasions, none of them are online. And there is some order before 9 a.m. And that order doesn't mean anything at all, because we don't know which friend is better than other friends. We don't know who are females that we give preference to or who are males among those n friends. So all of them n are equivalent. So it doesn't matter. All of them are same. So the initial list we have doesn't have any importance to the numbers, to the orders. You can reorder, you can rename these people like 1 2 3 4 5, and it will not change a thing, because because there is no importance before 9 a.m. That can be like one of the first statement we can think. Video got recommended in my homepage, damn. Because probably because Mohit, you have subscribed to me, right? I think that's the reason. So now I have solved problem rating of 800, 900, 1000, 1100, 1200, and now we are at 4 problems have been solved, and now we are at 1300 requested by this guy. I swear in the chat, SWER chat, that I have not solved this problem before. I have never read the problem before, so I think this works. There is another Mohit, which is not Mohit, Mohit Kumar, and Mohit MES is my college mate, I guess he's my friend. Uh, yeah, so now this order has no meaning at all. We can rename those things from 1 to n. It works. Mohit, the other Mohit, like Mohit Kumar, have you made this statement to yourself that the initial ordering doesn't matter? Have you made it to yourself? Like, that simplifies two arrays to one array, right? Because one is just 1 to up to so on, and the other thing will be renamed now. Hello Mohit Kumar, have you made at least that observation is what I'm asking. Yeah, you have made that. So now we have to use some logic to see if someone has ever came online. One thing we can definitely say is, if someone comes online in this list, they will be placed in the first. That's the algorithm now, right? Because if someone appears online, let's assume no one will come at see, make sure no two members are online ever at the same time. This simplifies that. We have a list of people. If someone comes online, they go to the friend, and then again if someone comes online, they go to the friend, and then if someone comes online, they go to the friend. So let's rename. For our simplicity, we will definitely rename. So a1 a2 up to so on an will be 1 2 up to so on n, and then we have an order. So now we have to find how many of these people have reappeared, so that m- at least they must have reappeared. Otherwise we may not find exactly who have reappeared, but maybe we can find at least this many people have reappeared. That's what they are asking. Using some logic, what's the minimum people that must have been online? Because whatever, if you consider all the possible ways that this could have happened, all the possible ways, among all such possible ways, we want minimum number of people that have came so far. This will be simple. Ordering after 9. Yeah, so we have a list of 1 to up to so on n, and then we have one permutation. We have a list 1 to up to so on n. Renaming is done. What's our question? So we have 1 to up to so on n, and then we have another permutation. So we want to see what happens. Someone in the beginning can cross 1 only. See, so I'll write it here. One simple statement we can write is, do, can people appear multiple times? So there's a list 1 2 3 up to so on, and some operations would have been I moving forward, and then j moving forward. Now we have a permutation. We want minimum number of people moved so far. Minimum. From this permutation, what we can conclude that at least this much people have been moved. I can say logically it has something, but still let's see if it gets simplified, because it's a lot easier problem, right? So If someone moves forward, they will cross one and they will cross everything smaller than them. But if again one cross to the front and two cross to the front and three cross to the front, then again the we may have no idea. So one thing we can say is, if see, people can only go to the front, go to the front. So if see someone, if there is someone large smaller, this is one necessary condition, necessary or one obvious logical statement we can make. And if it is an easy problem, just this would be enough to output the answer, most likely. Otherwise, we have to make sure that this is the, we have to prove that. In other ways, there is no way to say more people are possibly have moved. Have you made this statement, Mohit? Probably no, right? We have 10 people, we need viewers again. See, when we are going to interesting problems, people are on being there. Uh, so, have you made that statement, Mohit Kumar? This statement that if there is someone smaller behind I, means he has gone friend, so that someone is smaller behind. Otherwise, if before people are moving before, they will not change I's location. If later people are moving forward, again no one will be behind I who is smaller. Only if I moves, he will have someone behind him. Do you get that? So now, is it a necessary condition? If sufficient one, if I moves, will there be someone behind him? Because if I moves and then again somehow everyone came friend, then maybe not. But maybe then we cannot even guarantee things. So just let's assume like this would work because it's an easy problem. This would just work. What do you say? Let's see, if n has moved forward and then again 1 has moved forward, then both n and 1 should have been moved, right? 1, 2, up to so on n. If n has moved forward and then again 1 has moved forward, our logic will say n has been moved because there is something smaller behind him. But also 1 must have been moved. So this is not enough. We have to use a bit more logic. We'll solve this problem for sure. So here also 1 has been moved, right? Because things will only move to the front. See, we can make one more statement. If I has been moved, everything before that has been moved. What's this? I think these two are good enough. Have you made this statement, Mohit Kumar? Tell now. Say, bro, have you made that statement? That obvious statement, obvious fact. You have made that one too. So, which means If someone has moved, this thing can be used to say if someone has moved forward, and then if someone has moved forward, everyone before them has also moved, because that will help us solve this case. Okay, n has moved forward because there is someone smaller behind him, and everyone before him also have been moved, right? So this means this statement itself means finally some prefix is the one that has been moved, because if this guy has been moved, everyone before him has been moved. So this means this simplifies the structure of the people that have been moved so far. See, what's the final logic? You mean this one or this one? Sorry for this gap. I'm getting distracted, but yeah, answer isn't done. Answer I haven't gotten yet. I'm just telling that for this these two conditions are enough. That's what I have told. Even I haven't got the answer yet. But this is simplifying the whole thing. This just says a prefix, because have you gotten this line 37? Did you get line 37? And how it simplifies everything? Yeah, because if this guy has been moved, he will go to the first place. And then if he has came till here, everyone before him must have been moved. So because people that have been moved will form a prefix. This is the logic that we got. So if we can guarantee that this guy I has been moved, you're good. So we want maximum such I. Now I can see myself because I also can join my. What about screen? Is my screen visible now? It should be quick. Yeah. So see,
we want maximum I, which you can guarantee that has been moved. If you can guarantee using some logic, whatever the logic, and say that this is the last guy that has been moved, and you cannot say if these people have been moved or not, then that's it. Then you drop, spam the link in the groups, you know. So that logic is fine, right? So now, using some logic, you want to say these people have not been moved, have been moved. So if the lost group remains same, then they have not been moved, right? That we can say. But can we guarantee? But that's not the answer, probably. So, see, if last few people have been same, they have not been moved. But some people might have not been moved, but then they might have just came forward, right? Right. So, hello, can you hear me, Mohit? Yeah. So, last few people that have never been moved, they will stay right there. But only few people might have moved forward, and all of these people also might not have moved. So we cannot say for sure that they have been moved. We have to say for sure that they have been moved. So we may not be able to say that. So if you can find if you can find I think if you can find longest common subsequence between these two, let me tell you something. See, let's say this is the initial 1, 2, 3 up to so on, and yeah, let me tell you this. So we have a big thing. We claim, see, we have a partition. We claim all these people have not moved. We claim all these people have been moved. We should be able to claim these two things because it's a prefix. And what is such maximum thing we are telling? So now that means, that means, sorry, that means this behind thing is an increasing sequence. If this behind thing is an increasing sequence, then we can have other than those. Everyone else has moved forward and then they got jumbled like they want. So do you see the condition now? If these are the people that has not at all moved, then if we look at second part, then they have not moved at all, so they will be in increasing order, and we can always make the rest to move forward and jumble them as much as we want. So now is it clear now how to find the maximum lost people that that may not have moved at all? Then we will know minimum people that might have moved. So it's done now, right? No need. I will go quickly. I will go quickly. See, the stream is not going to end like within 3 hours or 4 hours. I think I'll go even if it is 7 or 8 hours until I can go. Maybe you can take a rest, take some rest in between, but I'm not ending till I reach 24, 25, I think. I hope I will not. That's why I have started it at morning 12 o'clock, right? Otherwise, I will start at night 10 o'clock. Uh, because I cannot cheat now. I told I will go over each rating because I cannot say now I will skip. So Mohit, is this clear? So it's all about logic. Do you see? It's not like getting some great idea. Yeah. Do you guys? I mean, see, this logic seems very clear now, right? So uh, the, we have to And then trying to look at people that not have mood is being easy. Like maximum people that not have mood will give you minimum people that might have mood. So if you try to look at maximum people that not have mood, all the decreasing sequence in this, you can make them they have not moved. So two must have been moved. 4, 5, 3, 2, 1. No one else has been moved. So 0. All the decreasing sequence. 3, 7 is decreasing because 3 comes before 7. And then 2 is decreasing. 8 is decreasing, but the rest are increasing. So 4 is the answer. So do you see you have your answer now? So instead of finding Master, I wanna bang your sister. Okay, it's working. But my screen where I handle things is yeah. I think this seems working. So can you see my screen now? Can you see my screen? Yeah, you can see my screen. So I will paste the thing that I have told here. See, maximum number of people they may not have mood. Here may not have complement will become must have mode. Will give you the minimum number of people that must have mode. So this has more order. This has more structure. So looking at it is beneficial to us. So should I just rename it and then go and find maximum decreasing sequence from the behind? Or should I, without renaming, try to see if both are same? Both are same. So I will rename them. Int n scene. I will use the second sequence only to rename. I hope you can see this. So first sequence, I'm not even taking it. I'm using it to rename. Now I'll take the second sequence as a permutation, let's say. You can see, right? Text me on WhatsApp like if something goes wrong so that I know. I mean, if you have some work, you can leave. I'm just telling, otherwise, I hope someone else will text. So right after getting, just let's again rename it. Now we want maximum decreasing from the behind. So mm, if something is smaller, it gets added. And if something is bigger, we cannot do anything now. We have to break. See, it was very complex logically, but looking at this thing now, everything is simple. That okay, maximum number of that may not have moved. These people may not have moved at all. These people may not have moved at all. Everyone else might have gone forward. The structure, the overall structure is still holding. That moved people will go forward. So some people that have moved has been in the forward prefix, and these people may not have moved at all. If they may not have moved at all, these are the minimum number of people that you can guarantee that must have moved. So it's very clear. It seems like there cannot be a good proof to it, right? Yeah, I got it. I got it. I know that because you have asked this question. I thought that. So this logic seems clear, right? Proof is also again simple because it seems like this cannot have a simple proof because it's being a bit complicated. But still, have you seen? So Grayson is not there, right? But still, even this thing has a simple proof. Hey, yo, sister, I wanna bang your sister. Can he not talk? He's there. See my solution, how clear and simple and neat it is. Don't you see that? Just increasing sequence at the end. Do you see? Yeah, you thought there will be a solution. You thought, okay, there is a complex solution to this. Maybe you have to do something magical. But that's what. Whenever we can solve a problem, we won't be believing our golden rules properly. If you believe in the golden rules, you will try to find a way in which you can prove easily. Okay, the things that must have moved seems complicated and critics is there and lost things are there. Maybe it's easier to prove these things may not have moved. So that's leading us there. So you should not try for something great, something weird, something complex. You should see doing simple things is hard. When I say golden rules are simple, doing simple things is hard. You should just try to do simple things again and again. This will be accepted, I think. See, it's again accepted. So it's accepted. Yeah, if you want, you can. Someone else will be there, and I can try to proceed further. So now we are at 1400. Now we are entering specialist zone. There may be people who have never reached specialist. There may be people who think specialist is too hard, right? Hello. So now we are trying to change it to specialist thing because I should go quicker. Mm, see, is good, but guessing it is easy. People may guess it. If they try to find two, three guesses, they may think, okay, it seems like these things have not moved. They observe the things and then they think, okay, these things have not been moved. So they do that. You see why it is a bit less difficulty problem. Problem is good only. It's not that bad. Yeah, it's a good problem, I can say. Not too good, but yeah. So now we are entering 1400. Don't get scared. It's just 1400. I consider all these as newbie problems only, I think. Is there any good name? Alyan permutation seems a good name. I hope I haven't read this before. I think I have read this before. See, I have read this before. So let's go to some other problem. RNGCD. I think I have not read this before. See, you may say it's impossible, but how difficult is it to look at the complement? It's the very basic thing, right? When this thing is looking complicated, looking at the complement. Oh, that's what you mean by complement. Okay, now I got what you mean by complement logic. Yeah, it was simple. You have complicated it for yourself. Yeah, you can join later. Bye. So now we have 1400 problem. What were you kidding? We have 1400 problem. So we will solve this instantly because we have solved 2000 problem in last stream, right? So 1400 is an easy one. So we will solve 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and so on. So I'll try to solve this quick. You're given an integer array of size, then you can perform the following operation as any number of times. Wait, can I edit and add? So can anyone give attendance, whoever out there? You can perform the following operation any number of times, like W in the chat. I think that will not work. You can perform the following operation any number of times. Pay one coin and increase any element by array of the array by one. You must have at least one coin to perform this operation. Gain one coin and decrease an element by. So you will pay one coin and increase it. You will gain one coin and decrease it. This means number of coins and the sum of array is constant, because a coin gone into the array, array came back. So operation seems simple. Let's say that an array is ideal if both of the following conditions hold. Each element of the array is at least 2. For each pair of indices, the greatest common divisor of Aij is 1. If the array has less than 2 elements, the condition is automatically satisfied. So we want, because we can make everything 1 and then claim GCD of everything is 1, they are telling each element is at least 2, and so we have something called ideal. An array is ideal. We have some conditions on ideal array. Let's say an array is beautiful if it can be transformed into ideal array using the aforementioned operations, provide that you initially have no coins. Initially you have 0 coins, but still we can decrease them. Can it go negative when we decrease? I don't know. But finally it should have like this. So the operation just says you can reorder them as you like. You can just, sum is constant is the only thing the operations mean, because you can get them into coins and then again you can put them back. But then sum is not constant. You can have some coins, sum of coins plus that is constant. You can have some coins and then you can reorder them as you like. Remove everything into coins and then again put as you like. So okay. So this has multiple things. That's why it's a good and easy problem, probably. Who are those 3 viewers and 2 viewers? We need viewers. So So we can remove few elements. Means you can remove 1 minute. Hello, am I audible now? Yeah, so we are at 1400 problems now after the break that I have taken. Let's try to solve the 1400 problem that we are trying to solve. Yeah, this one. We have to remove few elements. Here we need not remove anything. And we can make this 4, 3, 5, and it's a beautiful one. And it's an ideal one, ideal array. So we can. Hello, is anyone there? Hello, hello. So we have something called an ideal array, which means there are some conditions. And now we have to remove few elements from the array so that it can become an ideal array, it seems. So 535, we need not remove anything and it will be an ideal one. And 234, 2324, here they mean you need to remove two elements so that they becomes beautiful, it seems. Even if you remove one element, it will never be beautiful is what they are telling. So if you leave the elements 2, 3 and delete, GCD of all the pairs should be 1. GCD of all the pairs should be 1, it seems. How can you make GCD of all the pairs 1 when all of them are greater than or equals to 2? Is there anyone else that's trying to solve that problem? I'll keep it here. So it's 1400 now, and we have GCDs. Maybe we'll get scared of GCDs, but I think GCDs are not to be scared, I think. So they mean GCD of all pairs is 1. Means all of them are co-prime, which means all of them are co-prime. Means if there are some prime factors in A1, then they cannot be in A2, then they cannot be in A3. Do you guys get what that means? We don't have that many prime factors at all, right? Is anyone there? Who are these three viewers? Non-responsive viewers. I'll just solve it as if this is not a stream. Okay. So we have to, all of them are like, all of them are like, all of them should have different co-primes, like completely different co-primes. And some will be fixed always. So we have to remove so many elements in some cases. Wait, but how is this is 0? Oh, okay, we can reduce this to 99 and then maybe we can increase this to 5. We can add, yeah, so that is fine. So one thing we can say is, but how can we find the minimum number that we have to remove so that it becomes beautiful? There can be many number of primes less than or equals to 10 power 9. how to solve the problem. So what will I do is I won't solve this problem because our rules only say I have to solve one 1400 before going to some other thing. So I'll just skip that and solve some other 1400 problem because I don't want to waste time. This seems a bit nicer problem. I'll maybe come back to it later, but yeah, for now I'm just skipping it. You're given three non-negative integers b, c, and d. Please find a non-negative integer a such that a or b minus a or a and c equals to d. So we have b, c, d. We have to find this thing. If such an a exists, print its value. So this is a good problem. We have something to think here. I mean, even the previous one is a good problem, but I have not solved this. Yeah, I think the GCD one is also good because, but the thing is, number of prime factors, it should not be difficult. I don't know why I can't solve some problems at all. Mm, I need water, I think. The minimum number of elements you have to remove. But yeah, I will maybe come back to it later. But for now, for the stream, I want to proceed to as many, as many problems as possible. So I will try to solve this quick, and then I'll try to go because I want to go to higher ratings, right? So A or B minus A and C equals to D. So bitwise minus A and C equals to D. So guys, if you look at each bit individually, if you look at each bit, see, we should be able to prove if an A exists or not. We should be able to prove this thing, if such an A exists or not. And if it exists, we have to find any of that. And we should also prove that, okay, an A doesn't exist in this case. So, because solutions are simple, proofs are simple, implementations are simple, we have scope that, okay, we can actually prove things. We have people. Yeah, you can try, you guys can try parallelly. So if you look at some individual bit, that can take values 0 minus 1 or 1 minus 0 or minus 1. It can take values 0 minus 0 or oh, okay, we have B here and then we have B here. Maybe we can, okay, this is D. Yeah, so there is no relation between them. Okay. They can be 1 minus 0 or 1 minus 1. So there are three different possible values for each bit based on the bit's value. It can either be minus 1 or 0, right? There are three possibilities, 1 or minus 1 or 0. I think it's like it's more of like a DP restriction, right? Like that this bit can only have few of these states. When A is 0, we have this or this, right? It's more of like a restriction. And now what we have to see is, if we look at k bits, okay, with 1 0 minus 1 0 1 0 minus 1 up to so on. Okay, let's look at this thing. Okay, if you look at k bits, let's assume the first one is 1. Okay, now even if it is here, this will make the whole sum as less than or equals to 2 power k. 2 power k will have the even bigger thing, right? Even if it is minus 1 0 up to so on, that will make it less than or equals to 2 power minus 2 power k plus 1. But then the total possibilities should be, I'm unnecessarily overthinking, I guess. I think some things will repeat because 0 0 is same as 1 and minus 1, right? Not it's not same. But I think something should be repeating because it's just 2 power, and 2 power cannot have 3 different values taking different things. Where are we? Okay, if we even leave that, why am I not able to solve 1400s? So let's try to think about it a bit too. Maybe let's look at what all are possible. Okay, what are all different states for a bit? It can be B0, C0. In this case, we have A as A. B1 and C0. In this case, it will be 1. It's B0 and C1. In this case, it will be 0. It's B1 and C1. In this case, it will be 1 minus A, whatever the bit we keep there. So these two are fixed. When B is 1 and C is 0, and when both of them are 0, when B is 0 and C is 1, this is A minus A, 0. So these are fixed. So all we have to worry about now is these bits, where B0, C0, B1, C1. Because we can subtract all these things which are fixed already to that side, and then we have few options of some powers which can be either A or 1 minus A. But A or 1 minus A are the same things when A is in your total control, because you can keep 0 or 1 or 1 or 0 in each of those bits, so it doesn't matter. This means we have some fixed bits. We'll just subtract them, and then some fixed bits, let's remove them from D, and now we have some variable powers. Wait, yeah, some variable powers, because this thing is likely greater than this always, so it won't become negative. It will never become negative. Here, what am I looking at here? Okay, I was just saying all possibilities, but they won't even become negative. If you look at these things, because this is or and this is and, they won't even become negative. Let's just look at what we are doing here. Okay, is there anyone? So that's why this problem is easy, because most of it is fixed. Because most of it is fixed, this is an easy problem now. So we can subtract all the fixed ones, and a and 1 minus a are same because we can keep 0 or 1. It's totally in our control. So now we have d minus fixed things and some 2 powers. If this 2 powers, so let's say d minus fixed thing is d prime. Okay, if d prime's binary representation falls perfectly within the bits we have here, so within this variable bit powers we have, we are done. Else it's impossible because we only have these bits, and binary representations of d prime, we have to make d prime using only these bits, then it's impossible. So let's say we find d prime, okay, and we take the mask of control bits. Now it's let that be c. Now answer is d prime and c equals to d prime, because all the bits of d prime should be contained within the c. So this can be answered, yes or no answer. And once we know it's yes or no, we can choose based on these two states. Should we do 1 minus a or a based on binary representation of d prime? That's it. This is the condition that decides yes or no. And once we know that condition, we know d prime. Based on that, we know a and 1 minus a values, and then we'll return a. A is unique. A is unique or it doesn't exist. So we are done with that. Anyone follow this up? So it's just case while seeing bits. When what happens when B0, A0, B1, A1. In all these cases, it's either A because it's A because it's A minus 0. It's 1 because it's 1 minus 0. Yeah. It's 0 because it's A minus A. It's 1 because 1 minus A because it's 1 minus A. And 1 minus A minus 1 are different. This will only be used finally based on whatever the states we found out. Is anyone there? See, finding when it takes minus 1 is half the problem. Finding when it takes minus 1 is half the problem, because this is the main problem. We may think how to find that, yeah, doing some weird things and all, but we don't do weird things. We just mathematically solve the problem. Logically, mathematically, we just solve the problem. That's done. So I will implement it because this is a clear implementation, right? I'll maintain states for each bit, which will be either 0, 1, 0. So we only have to maintain a and 1 minus a. These two only we have to maintain. Other things we need not maintain because we will use them to find the a again backward. So, but even that we need not maintain. We need not maintain anything because it's simple. B bit equals to C bit. That's simple thing to do. So we have two cases. B bit equals to C and B bit not equals to C. Yeah. So see, if you see Durgesh, overall, is it a difficult problem? If you try without applying logic and if you try to randomly see what A will work, what A will not work, that will not work out. If you try to make logical statements that you can make, it makes so much sense to just see all the possible different configurations for bits, right? It makes sense to just look at that because there are many bits, but these are the configurations that repeat. So why not let's just look at them? And once if you look at them, it's very simple. Like, okay, it takes a 1 minus a and a are same because a can be either 0 or 1. And this is fixed, this is fixed. If something is fixed, we can move it to that side and then we have that thing. And then Now we only have few powers we can take, and whatever the bits that are active in D prime, we can only take them. So yeah, it's very simple one. So let's do this. Just need to figure out between the bits. Yeah, if you just make this statement, it's done. Now it's done, and then it's a simple problem. But if you don't even make this statement, and then if you think, okay, it's a difficult one, how to use it, how to do it, then it's difficult. So if you see, even if you do a little bit of try, problem, right? Looking at this should be the basic step, right? What anyone can do. I don't know why I have written something else. Maybe I was drunk a bit, but now I am fine. Int B C D. Scene B C D. Let's go over all the possible bits. And then I will find active powers. And I will also find D prime, which I'll just subtract from D. See, if both of them are active, if both of them are active, instead of writing this, I will just say bi, bit of ith bit is equals to b, and b ci equals to then this will turn into, if both of them are active, this will turn into a or 1 minus a. But then again, we have to check if it is 0 or 1. Finally, we can do that later. Active or equals to 1L of I, right? Else, only in this case we subtract. This we need not subtract. Else, if bi and not ci, where b is active but c is not active, we have to subtract d minus equals to, if d less than 0 or d and active not equals to d. This is bitwise, and active are the powers we have now, and d is the powers we need. If all the powers we need doesn't come from that, then it's -1. If all of them comes from that, then now let's try to make our a. Okay, and a is likely equals to d, right? A is d, a is just this d, but we have to flip some bits. On what bits should we flip? What bits should we flip? Whatever the bits that are here, we have to flip all of them, because we have to flip all of them, because this a is just d. Now a is just d, but in the actual a, if you want to go from the active positions, d is there, so it should be d. But in a, from after like conversion, like after this conversion where we apply everything, some bits will be flipped, right? In active positions, some bits from a are as it is, some bits are flipped. So that's what active is. And now we know the state of active, which is just d. So we just have to flip the bits that we have to flip, which are like, these are the bits that we have to flip, where bi equals to ci and bi equals to not equals to 0. We just have to flip those bits. Why is it 61? Why is it 61? It's not needed, right? Ah, it's not needed. 60 should be enough because D is only decreasing. 60 should be enough. Maybe to confuse they gave us. These are the bits we have to flip. I'm just flipping those bits. A is unique, so this must match. I think A is unique. See? It should be 1, right? It should not be 0. This should be 1. Yeah. So we have wrong answers. I don't know why am I doing all wrong answers, but is the solution clear to people? I had a guy asking me more videos, but then where is that guy? Like, is A not unique? Because D prime got fixed, which fixes what all the bits we have to take in. See, D has unique powers, right? Fixed powers, and A has set of powers we can take from all of them that are there here, and we should not take anything that's not. So A is unique. I think I just made some small mistake. I'll just check it. How is it -1? So I'll just try to check it. It's 1 0 0 1 0 0 0 1 0, and we have this thing. So our D will become 0 and A will become select minus. Wait, something we are missing something here. Okay. So let's just check this -1. Why is -1? And then we can just submit it probably. So we are subtracting 1 0 0 1 cases. In both of this, whatever the A is, it will be 1. In here, whatever the A is, it will be 0. Okay, we should not subtract this. So yeah. So 6 will become 2. And now 2 is not active. So 2 is not, it should have failed here. It should have failed here. So I think this bracket had an issue. This should have worked because the bracket had an issue because D was 2 and active was 1. So it won't match up. We don't have all the bits we need to make D in. So this should have failed. I think that was a bit error. Like I haven't wrote it properly. That's what the error is. Now we will get -1. 4 is also possible because that's the best thing that we have. It's not unique because in 0, 1 and 1, 0 cases, we can have whatever we want. Yeah, it's not unique because of the case where 1 equals to 0. And see, do you get Durgesh? Can you see this thing? In this case, A can be anything. In this case, in this bit, A can be anything. So it is unique in other places, the actual places. So here we can give whatever we want, and it won't affect. So in that way, it's not unique. You got what I mean now? You get what I mean? So it should be accepted, right? Yeah. So it got accepted. 1500 problem, what it all demanded was just some case verification. What happens when A is B0, C0, B1, C0, 0, 1, 1, 1, and then A 0 or 1, 0 or 1. Full freedom is there. And now, can we make this bitwise representation? Bitwise representations are unique. I think all of us know that because double double is unique. So we are done. So, so see, isn't it a smart? I would have wasted unnecessary time on this because I'm being bad. I'm not bad. I can surely solve it, but I'm unnecessarily using more logic in it. It should not use any logic. But yeah, let's skip it. Let's go to 1500. Yep, we can do that. See, they wanted to make it simple, so they kept 1 or minus and because or minus and is always greater than 0, na? That's why they kept it like that. Or minus and. But if you keep or minus or, it may become more complicated, which I was trying to solve in the beginning. I was trying to see, okay, what if there are some minus ones and if there are plus ones? But then or minus and will always end up in positive things. That's why it was even more simpler. Yeah, that's it. But the active bits are fixed. You see that, right? Beautiful way I have used to see if to see this and of something equals to and. If this is the submask of this, we can use this thing. This small and simple code. Codes will never be difficult. It's all about solution, getting the solution. It's all about getting the solution, I think. So now we will go to 1500 and see how difficulty will increase. Will it increase? All I am is a man. I want the world. The recent high rated problem that I have solved was 27 in contest and another 25 in contest, another 24 probably in contest, another 24 again in contest. I solved all of them in contest. 23 in contest shouldn't be anything. You guys can see my screen, right? I didn't get, but we can't fix the condition means. Okay, whatever. Uh, 15 days or yeah, I mean, the thing is, any rating will not use complex things. That I will prove it today by solving all ratings till 3000. So we have to be quick. So let's go to 1500. Can I understand what question is? So we have 1500s now. I have opened it already, so I will not open it. Maybe I'll open this thing. I think I have not read this problem, so let's try to read the problem and see if it has anything. Flower Boy has a garden of n flowers that can be represented as an array of integer sequence, with where AI is the beauty of the ith flower from the left. Igor wants to collect exactly m flowers. To do so, he will walk the garden from left to right and choose whether to collect the flower at his current position. The ith flower among ones he collects must have a beauty of at least bi. Among the ones he collects, so how many will he collect? M. M less than or equals to n, yeah. Igor noticed that it might be impossible to collect M flowers that satisfy his beauty requirements. So before he starts collecting flowers, he can pick any integer K and use his magic wand to grow a new flower with beauty K and place it anywhere in the garden. Between two flowers. Before the first flower or after the last flower, because his magic abilities are limited. He may do this at most once. Okay, he can only do this at most once. We can edit the current array at most once, and then again we have the same problem. At most, not exactly. Are you reading the problem with me, Durgesh? Output the minimum integer k Igor must pick when he performs the aforementioned operation to ensure that he can collect m flowers. If he can collect m flowers without using the operation, output 0. If it is impossible to collect m flowers despite the using the operation, output -1. So these are three cases. Until we try to work on the problem, we don't know how difficult or easy a problem is, because this could be 27, 28, or any rating. Until we solve the problem, we don't know if it has any nice logic in it or any nice conditions that we finally get. Da, 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 da. I want to go quickly, like at least after solving this, we will go to 1600, right? And then I want to go at least 19 because time's not there. We have to be quick. I think it's a bit brute force thing, shitty brute force. One thing is to find this k, we can maybe binary search. But let's say if there is a k, is it possible or not is another question, right? To find the k, maybe we can do binary search. See, here in this rating, like in this 1500 rating, there won't be good problems, but there will be like this shitty. All problems are shitty. Uh, all problems are shitty. Mm, mm, mm. So this is one operation. If we can edit and then see if we can, if it's already good, we are done. It seems we have to output 0. If we can add one element and then make it good, then we have to output what is the minimum value we can add, and else we have -1. So how to find first thing when it is 0? So you should be able to find something greater than or equals to b0 and something greater than or equals to b1. It makes total sense that greedy will work, because if you can fix a b0 right here itself, why go further? Do it right here itself, b0. So this is greedy. This greedy will work, right? So this is clear. And so this we can check if it is 0 or not. And there is one other thing now, because when we add some k, that will divide. If you add k here, that will divide the whole array into two parts. And now you cannot brute force. You cannot brute force on k position and then again do O of n to check if it's possible. See, we do this O of n to check if it's possible, right? But then again, we cannot say, okay, k is here, k is here, k is here, can be brute force now. We cannot do that. But if you see the structure again, the structure has this thing and this thing. There is something before k, let's call it L. And there is something after k, let's call it R. So instead of doing greedy from one side, if we maintain how many, if we come greedy from left side, how many things we can fit into L if you maintain that. And if you come greedy from right, how many things we can fit there if we maintain these two. Because if you are able to come greedily from left side, we can also come greedily from right side. So now we are dividing the B into two parts, and then left part will say how many greedily you can take till here, and right part will say how many greedily you can take till here. And now they both will not add up to k, add up to m, because if they add up to m, answer is 0 already. They will, if they add up to m minus 2, like everywhere, let's say everywhere for all these partitions of L and R, if they add up to uh so so do you guys see the problem now? Hello. So this is a basic technique which says that okay, we have to brute force, but if you move k a bit rightward, L is not changing much, R is not changing much. L is always prefix, R is always prefix, suffix. Can we store information nicely about L already? We can. If we just run one from the left, we can store all the information needed for greedy L. Greedy R, we can store all the information needed for greedy R. Now, array, we will split it into L and R. We know number of things on this side that we can greedily fit. We know number of things on this side that we can greedily fit. If they both add up to greater than n, m, we are done. Greater than or equals to m. It will be less than m, because it's not possible to do that. Because it is less than m, now we have to find that if it is m minus 2, we cannot do anything again, because adding k can only satisfy one more thing. Adding k can only satisfy one more thing, right? So the structure, we are trying to split the optimal B structure into wherever k is there, the k is being used, otherwise it's useless. So there is an element between k, and then we are trying to greedily move this part into this direction and this part into this direction. So that's the optimal structure. there is something below k, like b of I, and then we greedily going on to this direction b's, remaining b's, greedily going into this direction, remaining s. And we can calculate these things and these things prior, and then we can assume that, okay, if this and this size is equals to, count equals to m minus 1, then k equals to minimum of current k comma b of I. We know I things are here, and then b of I plus 1 we can find it here. Do you guys get that? What is the operation? We can fix the lower bound to find upper bound. I don't get it exactly what you mean. I'll get some water. But do you guess what? Do you get what I mean? We are just seeing the optimal structure, and then we are trying to say, because k is dividing the array at multiple parts into the middle, we still want to brute force this. We cannot brute force k and then do this, but we can brute force on k's position, and somehow, instead of doing O of n, find what we need smartly. It's not too smart, it's just storing. That's it. So we still, logically, we cannot do anything else but brute forcing k's position, because otherwise it will be much difficult problem. So even if you don't solve the problem, you can make this statement that, okay, I will definitely brute force k's position, because if you don't apply such constructive facts into your solution, like, okay, I am definitely going to brute force k, you cannot proceed further. If you think, okay, without brute forcing k, how can I solve this complex problem? You cannot at all. Logically, you brute force k, but then after brute forcing k, you will do something better. That's how you solve problems. Because if someone is able to make more logical statements than you, they might have assumed something and proceeded. Because if we assume that there is a simple solution, brute forcing k's position seems to be the simplest, right? Otherwise, you cannot prove. Otherwise, you cannot prove that, okay, k doesn't exist at all now. Without brute forcing k's position, which has so much complexity. If you don't brute force k's position, I don't think you can get a simple proof that says, okay, this is the proof that there does not exist any k. Do you guys get how to use my proofs or simple, solutions or simple, implementations? Sorry, solutions or simple, proofs or simple, implementations simple. How to use it is, you can assume k must be brute forced. Otherwise, you cannot have a simple proof for it. And if you're assuming k must be brute forced, then there is no option but to look at how can we smartly do this instead of doing off and again and again. And if you look at that, okay, k position is being brute. If you look at k position, there is something else and there is something r, and then there is some element between k in the optimal structure. We want to see if we can fit all the remaining things here and here. For that, we can try to see what is the maximum number of things we can fit in L by trying to greedy on this side and store it. Trying to do, because we must store something, otherwise we cannot do within O of n. All these things are directly being given to us logically. If you believe that proofs and solutions and implementations are good. So do you guys see how to solve a problem generally? Yeah, I mean, the idea will work, but what I'm trying to say you here is, if you believe in my golden rules, it's direct. There is no other way but not brute forcing k's position, because otherwise you cannot prove it. So all the solutions that have been submitted on this problem have brute forced on k. So it's that obvious and it's that necessary. But if you're thinking in the context, okay, how to solve it before brute forcing, without brute forcing k, then that's the mistake that we make, and some people don't make. You should know what to brute force. One viewer, but still I'm shouting this much. I think I shouldn't. Yeah. So we find this, count equals to m minus 1, count left and count plus equals to m minus 1, then this, else minus 1. So k will be some element from B of I whenever it's possible. So I will just initialize it to 1e10 or something. 1e9 plus 1 I will initialize it to. We're doing greedy from that other direction. N minus 1 is 1. So j would be, when j equals to m minus 1, answer is 1, right? So when j equals to j, answer should be probably m minus j. It's simple. Like number of things that we were able to fit in. Now. When j equals to m minus 1, we are still trying to fit m minus 1, but we were not able to fit m minus 1, which means answer should be 0. When j equals to m minus 1, we are still trying to fit m minus 1 because here we are trying to still fit m minus 1. We are not able to fit m minus 1 because j here will have what we are now trying to fit. Because if you are trying to fit j's index, how many we have already fit would be m minus 1 minus j, right? M minus 1 is the last index, j is the thing that we are trying to fit. So what has been so far fit would be m minus 1 minus j. Now let's brute force on k because we must brute force on k, right? Keeping it front will work if, and what should we output? Yeah, keeping it front, keeping it at the end. Let's just say keeping it at the front. That means CR of 0 equals to m minus 1. M minus 1 means we got everything. And see, if CR of 0 is m minus 1, also CL of n minus 1 will be m minus 1 because at max only m minus 1 things we were able to fit. Right. And we need not check again, I think. Everything will be m minus 1 because if you split here, everything must add up to m minus 1 perfectly at every split. maximum number of things into this, maximum number of into this things into this must be m minus 1, because if they are greater than m minus 1, that means we are forming m. We need not check that again. So we can return minus 1 right here. Right here we can return minus 1. I mean, we need not use this complex logic unnecessarily again into the problem, but I'm just using because I can. Now again, I need not check anything now. I can just write. Now it can be minimum of V0 or V of 1 or anything. It can be anything. It's just minimum of V. Because take the minimum of V and find the place where you can greedily fit. So questions are even simple. The solution is even simple now. Solution is implies and implies count equals to m minus 1. Wait a minute. Being able to fit first m minus 1 is different from being able to fit some m minus 1. So let's not make these assumptions, because I thought, okay, there are only m minus 1 things, but then these assumptions are wrong. Let's brute force it. Let's brute force it. I'm sorry for that. Let's just brute force it. Do you guys what I mean? Because I thought like there are only few m minus 1. I thought both are same, but then this m minus 1 and this m minus 1 are not same. Right? Yeah. The sum adding up to that and this is not same. So we have to brute force on case position. Now let's brute force on case position. If CL of 0 equals to m minus 1, that means, yeah, it's true, because CL of 0 can be m minus 1, but CR of 0 may not be m minus 1 because the last element might not exist at all in the array. So that statement I made was wrong. In that, while making a statement, I assumed only m minus 1 things are there, and then I thought, okay, everything is logical, but now it's not, because the first m minus 1 and last m minus 1 are not same, right? CL of m minus 1 means first m minus 1 things are able to fit in this. So but it's true that it will not, these two will not add up to CL of I and CR of I plus 1. These two will definitely not add up to M. They cannot be M, because if they are M, the final answer will be M. M involves all elements. M minus 1 will miss few things, but M involves all, so they cannot be M. If they are M, we can make it. It's not B of I, but B of CL of I, because CL will have number of elements in I. The next thing will definitely be CL of I, will be the right index. I overkill problems, but what it means is 4 will go here, 6 will go here, but we can have 6, 4, 2 here and 4 here. So this should not have been minus 1. Do we have viewers, or am I the only one talking? So this is an easy problem. I don't get why it is. So I'll just check about CL and CR if we are finding them correctly or not. Hey, oh, mister, I wanna bang your sister, bang your sister. I don't like errors. I should be careful. Wait, we are having 0 to this, and even that is wrong. What is the third test case? 0 is wrong for this, right? How do we report 0? Yeah, we should be careful. We can't make such mistakes because last contest of mine has been ruined because of such mistakes. In this contest, it got ruined because of such mistake. I have solved C at 1 hour 32 minutes. Even before that, I have solved, and then I was debugging on GDB. But then the mistake was L and I, and then it got accepted after contest. See, I would have been much higher rated, right, than I am now if I have just solved that in the contest. You should not make such mistakes. Let's just submit it. Now we will enter Mosh expert level after this. Yeah. Here we go to 1600. So this brute force problem has been done. It has no logic at all. It's just brute force, shitty brute force in case position, and it's obviously direct that there is no other way but brute force in case position. And the shitty problem code is also very simple. Simple shitty problem. Yep, I took a break. I took a break from I ate and then I came at 12 o'clock. After eating, I came at 12 o'clock and then I took a break at 2 to 2:30, 2 to 2:25. So now we are going to 1600. Are you guys scared of 1600 problems? I surely am not. Flow round still sounds nice. Should we try to go for that? But then why is it unrated? And why is it 1600? Okay, it is division 1B. Division 1B? Division 2 C. Okay, I have solved division 2 C. The fuck is this? Oh, both are same problems, but I have solved a bit harder problem, I guess. It makes no sense to solve it now because I might have solved a similar problem in B. I'll get some water.